All right, so let's move to problem 3. Okay, so for A, we have the Laplace. We want to find the Laplace transform to the sine square 1 over 2t, or can be written as t over 2. All right, so the very famous mistake done by the previous students. Okay, so what they did is this. Okay, so this one equals 1 over 2. So they take out 1 over 2 because they think that 1 over 2 is a constant, okay, which can be put aside before the Laplace notation. So what they did equals 1 over 2, and in the bracket we have sine square t. This is very, very big mistake. Okay, because 1 over 2 is actually the angle to the trigonometric function. Okay, so this is not right. Okay, so this one is actually, okay, if we write carefully, this is the Laplace to the sine square t over 2. So t over 2 is the angle to the sine square. Okay, it is not similar to the 1 over 2 sine square t. All right, so we cannot simply take out 1 over 2 to be put in front. Cannot be done that way. Okay, so this is, okay, a very big mistake. All right, so what do we do with this? Okay, sine square t over 2. So if we refer to the table, okay, we do have sine at, but we don't have sine square. Okay, so again, we need to think of, okay, how can we manipulate the expression here so that we have either only cos or only sine term. Okay, so we need to have the identity. Okay, the identity of trigonometric function. Okay, so if we refer to identity, okay, so we need to look for sine square. Okay, sine square. So we have here sine square, one here. Another one is here, sine square. And this is another sine square. Okay, but let's say we choose this one. We rewrite sine square in terms of 1 minus cos square. So we still have square function. Okay, so this one is not related. If we choose this one, we rewrite sine square in the form of cos 2x and cos square x. Again, we still have the square function, which need to be written further in other form. All right. So the only thing that is applicable to be used is here. So cos 2x equals to 1 minus 2 sine square x. Okay, so from the identity, okay, so we have the identity cos 2x, okay, equals 1 minus 2 sine square x. This is what we have from the identity. Okay, now we want to change accordingly, okay, based to the term that we have. All right, so we have sine square t over 2. Okay, so I'm going to change here sine square. So now x becomes t. Okay, furthermore, we want to have x over 2, which is t over 2. So I want to change this one to be t over 2. All right, so by right, if it is x, okay, if it is x, then at the left hand side it is x as well. Okay, so now if I change to t over 2, then you can see that at the left hand side it becomes t over 2. Other than that, it just follows. All right, so what we want to rewrite is actually this. All right, so at the left hand side, when we have t over 2, so we can see we can simplify that one because 2 is actually the angle. Okay, 2t over 2 is the angle to the cos. So we can cancel out 2 and 2. So we have actually cos t at the left equals 1 minus 2 sine square t over 2. Alright, so it means that the Laplace to the sine square t over 2 can be written as, okay, 1 minus cos t, okay, over 2, okay, because we only want this term. Alright, so 1 minus cos t over 2. So we have the Laplace here. So now, by the linearity property, we know that, okay, the fraction 1 over 2 is a constant, okay? Or basically, we can write as the Laplace of 1 over 2 minus 1 over 2 Laplace of cos t. All right? So now, individually, okay, we have those terms in the table. All right? So the Laplace of half is the Laplace of a constant. Okay, so we can refer to the Laplace of k. Okay, so the Laplace of half is half over s, or 1 over 2s, minus 1 over 2 Laplace of cos t. So we look here, cos at, and the answer is s over s square plus a square. So in our case, a is 1, so we have here s over s square plus 1 square, okay, which can be now written as 1 over 2s minus 1, s over 2s square plus 1. Okay, so that's how we solve the first problem. All right, so for B, I'm going to just pass on that one. Okay, so for the B, you can try on your own. The answer for B, you are supposed to have the answer for the B is 3 over s plus 4 square plus 9. Okay, so later please try on your own. All right, so I'm going to proceed to C. Okay, so C, this is C. We want to find the Laplace of t squared. So we have t squared sine 5t. Okay, so I'm going to put the table here. All right, so now, so we have t squared multiplied with some function sine, okay, sine 5t. So if we refer to the table, we have t power of n here, but this one for a single term, t power of n. But in our case, we have t power of n multiplied with something. So the one that is related to us is actually this one. So t power of n times ft. Okay, so the answer would be in this form. Okay, so this term here actually need to be mapped to Laplace of t power of n ft. Then the answer is supposed to be in the form of -1 power of n dnf dsn. Okay, so by mapping to the t power of n ft, then we know that our n is what? Okay, 2, because we map t square to the t power of n. So n equals 2. So the other term is our ft. So ft is sine 5t. All right. So you can see when n equals 2, so our final answer is supposed to be, okay, -1 power of 2. Okay, which is +1, and here n here is 2, and n here is also 2. So it means we need to get the second derivative of f, d2f ds square. Okay, so we need to find the second derivative. How do we find the second derivative? Okay, we need to get fs first. If we know our fs, then we can find the first derivative and then we can proceed to get the second derivative. All right. So by knowing the ft, therefore, okay, we can get the fs because fs is the Laplace to the ft. So this is the Laplace to the sine 5t. Okay, look carefully in the table. We have sine 80, but sometimes students overlook, okay, with the sine 80 here. So careful. Look carefully. We have hyperbolic sine. So supposed to be here. Sine 80. So the answer, the transform is a over s square minus a square. So in our case, a is 5. Okay. So we have 5 over s square minus 5 square, which is 25. So that is our fs. But this is not our final answer. Okay, our final answer is supposed to be this one. Okay, here, d2f ds2. All right. So therefore, df ds, okay, we cannot get directly d2f ds squared. Okay, we need to get the first derivative. Okay, first. So df ds, so basically we differentiate f, okay, which is 5 over s square minus 25. Okay, so you can do quotient differentiation or you can do straightforward, okay, because at the top it's just a constant, okay, and do not involve with the s. So this one is actually can be written as dds of 5 s square minus 25 power of -1. Okay, so by that, okay, you differentiate term in the bracket, so we have -5 s square minus 25. Now the power becomes -2. Okay, -1 minus 1. But don't forget we differentiate s square. So we have 2s. Okay, which can be seen as, okay, so if we put back in terms of fraction, then we have -10s at the top. Okay, so we have s square minus 25 power of 2.
Okay, what we want to have is d2f ds square, which means we need to do one more time of the differentiation process. Okay, so we need to get d2f ds square. Okay, meaning that we need to differentiate one more time. Okay, the -10s over s square minus 25 square. Okay, so you can see we can put aside -10, okay, because it is a constant, so I can write -10, okay, so d ds s over s square minus 25 square. Okay, so differentiating the fraction here means we need to apply the technique of quotient. Okay, quotient differentiation, which is v square at the bottom, let v differentiate u minus let u differentiate v. All right. So the numerator is the u and denominator is the v. All right. So we have -10. So we have a big bracket here. Okay. So at the top we have v. So our v is s square minus 25 squared. So this is v. We differentiate u. U is s. So u prime is 1. Minus, we let u is s, and differentiate v. So our v is the denominator. So that is 2 s square minus 25. Now the power becomes 1. And then don't forget we need to differentiate the s square. So we have 2s. Okay. Over all of this. Okay, over v square. So our v is s square minus 25 square. Okay, so but we want to have v square, so it means bracket square square. So we have power of 4. Okay, so be careful here because sometimes students tend to write the bracket with the power of 2 only. Okay, so the whole thing here is our v. Okay, so we want to have b squared, so it means we have, okay, power of 4 at the bottom. All right, so and then a little bit of okay, a little bit of algebraic. Okay, try to simplify here and there, so we can see that. Okay, so we have -10. Okay, so we can see at the top we have s squared minus 25, okay, as the factor, so we can factor out basically. So if I take out s squared minus 25, okay, then I will have 1, we'll have s squared minus 25. Now the power becomes 1 because we already take out s squared minus 25. So, and then we have minus, okay, so we already take out this one, s squared minus 25. So what's left is 2s times 2 times s. So we have minus 4s squared. Okay, over s squared minus 25 power of 4. Okay, so we can simplify. So this one and this one. So now the power becomes 3. So we have, okay, inside the bracket. So we have, okay, s squared minus 25 minus 4s squared. So we have negative 3s squared minus 25 over s squared minus 25 power of 3. Okay, so and then that is our f double prime, basically d2f ds squared. So our final answer should be in this form. So we have -1 power of 2. Okay, so therefore what we want to get initially is the Laplace to the t square sine sine 5t. So it is -1 power of n, so our n is 2, so basically we have +1, okay, times d2f ds square, so we have positive, okay, and then okay, so we have +1 times -10, okay, -3 s square minus 25 over s square minus 25 cube. Okay, so even we can factor out the negative, okay, inside the bracket, so we have +10, okay, 3s square plus 25 over s square minus 25 cube. All right, so this is our final answer.